All right, good afternoon, everybody, or I guess it's still morning. Good morning, everybody. Welcome back to another live stream. All right, so this one today is a continuation on last ones, but it's not the continuation that I originally said. So just to recap what the last one was. So the last one we had covered a very high-level introduction to MLX. And as a brief reminder, MLX is this new Python-based framework, also a Swift-based framework that Apple themselves is developing that is intentionally designed to run these AI models on the new Apple Silicon hardware that came out just a few years ago. So if you're not aware of that, a couple years ago, Apple moved from using Intel as the source of their chips to using their own source of chips. And these chips are very fast and very efficient. So it's pretty cool to see what we can do with MLX. So I noted at the end of the last stream that what we would be doing is that we would be taking what we had finished in the previous stream, which was generating some text using a local quantized Mistral model. So if we're not going to cover that again, so if you want to learn more about that, I would encourage you to go back and watch that stream. But what we're going to cover today is, so I mentioned that we would be wrapping it all in this Gradio UI, which is still to come. But I would like to also make use of this within the LangChain framework. And so I quickly discovered that basically this was going to need its own stream, like if we were going to need to do this. So, all right, so let's go ahead and jump into things. So just as a reminder, we've covered LangChain before. It's been a few months, but since I've covered it, there's been some pretty big changes to LangChain. So let me go ahead and share my screen here. And let's go ahead and jump into, a little bit of a high level kind of thing here. So just as a reminder, I think I covered this before, but this is like the home page for LangChain now. And you can see that, they're offering different products. We've covered LangSmith before. We haven't really covered LangServe, and I personally don't have a need for that, so we probably won't ever cover that. Not covered templates, but the thing I want to call out here is now we have LangChain that's been kind of split out across a couple different of their own Python libraries now. And by the way, if you have any questions, I am taking any questions on LinkedIn or YouTube. So originally this was all like in the one core LangChain package, but now all these things have been broken out. So like, for example, the OpenAI integrations and whatnot have all been broken out into their own library. A lot of them are now as part of this like LangChain community. And then you can see in the LangChain core here, we have the LCEL or LangChain Expression Language, and we'll get to that in a little bit. But basically, yeah, so like everything's been broken out into this LangChain community or the LangChain core libraries. So we've had quite a few changes there. But I want to cover a very quick history. Oh, not that one. So let's go ahead and jump into our notebook here. A very quick history of how we used to do these sorts of things. So I'm going to need to do a couple of imports here. Import YAML. So for this first part, I am just going to be making use of the OpenAI API. But we will get to the MLX portion here in a little bit. So I need to import a couple things here. So from LangChain core.prompts, import chat prompt template, prompt. Did I not spell that? Oh, it's because I haven't selected my kernel. That would be why. I was wondering why it wasn't doing my autofills. All right, system. There we go. There's our autofills. Human message prompt template. All right, and I'll explain what I'm importing here in a second from LangChain core dot message. Well, I don't want to import that quite yet. LangChain OpenAI. So yeah, like I said, we're just going to be making use of OpenAI to begin with, not form from. Silly me. All right, chat, OpenAI. Okay, so we'll just start there for now. All right, so let me go ahead and load. So I have my my API key saved in this local file over here, so you can see that since it's grayed out under the sensitive directory, that means it doesn't get pushed back up to GitHub because those are sensitive credentials. So yeah, just whenever you're working with your own API keys or whatnot, just be very careful all the time to make sure that you are securely using them and that you're not, unintentionally revealing them to the public through something like GitHub. Okay, so with open, all right, so those are in my sensitive directory, sensitive / API keys.yaml as f. All right, so API keys equals YAML.safe load f. Okay, so now let's go ahead and set up the prompt structure. So just as a quick reminder, this part kind of doesn't change, but you'll notice now we actually don't, like, I think it's still around, like you still can do a LangChain.prompts like this, but like I think the more popular, or what they're trying to push people toward, is using like the actual core nomenclature here. Let me make that a little bit bigger for y'all. So yeah, let's go ahead and just set up this prompt structure. So the way that we need to do that here is we're going to have our system message prompt template. So this is like the meta message, if you will, message prompt. So I'm going to call this system message prompt template dot from template. And so we're just we can make this string whatever we want it to be. So we're just going to say for now, you are a helpful assistant. Okay. And then, oops, I didn't put the equal sign there. All right. And then, so then human message prompt equals human message prompt template dot from template. All right. So this one's going to look a tiny bit different here. So just here, let me type this out here. So, input. Okay. So you might be noticing that we put some curly braces here. And then you'll notice that it's got the word input here as orange. Now this word is arbitrary. Like this could have been anything. In fact, just to make it clear, let's call it David's input, just to make it really clear that this is arbitrary. That wasn't a special keyword, because what's going to happen here is that when we invoke this chain, is like this whole thing is going to get kind of mushed together, if you will, as like a single prompt, and then but at the time when we invoke it, then we are going to put whatever whatever we want in here. So it could be, what is the capital of Illinois? Why is the sky blue? Whatever we want. So that's what this is representing here. So, and then we can combine these two together. And this is all old stuff. Like this is nothing new, but we're just setting it up for what we're going to be doing here in a little bit. So chat prompt template dot from messages, and then we need to pass in a list of the two things that we just set up at the top here. Now, one thing I do want to address really quick, because you might be wondering, is it actually necessary to have like a system message prompt template here versus just jamming it all into like the human's message prompt template, or vice versa? And the answer is there's actually not. Like, technically speaking, there is no difference between these two. It's just that I think if you were to use, let me go back here. So Langsmith, so this very specific UI here, we've covered this before, so I'm not going to cover it again. But basically, this is like a UI product that LangChain is housing. And so like if you connect this appropriately, then when you do all your running and stuff, you can see here that it will do all of the logging appropriately. And so it will log it, like there's like metadata stuff that's underneath here that it'll tell, like, so when you log into LangServe, it'll say, okay, like we are using this very specific system message prompt template or human message prompt template. So I think it's probably still best practice to use both of these separately as they are, but it doesn't matter. Like, technically speaking, it does not matter. Especially with our MLX stuff. Like, our MLX stuff is not, they're not, at the end of the day, well, we'll get to it, but basically you'll see, like, we're just going to jam these things as a single string, and they won't be recognized as these two separate entities as they are right now. Okay, so let's, so that's our chat prompt. Now let me check my notes here really quick. Okay, so let's go ahead and instantiate our model here, or LLM from chat, or let's call this OpenAI LLM for now. We'll change the name here later to be a little bit more generic, but just to make it clear, so we're going to call this chat OpenAI. We imported this from above, and the only thing that we're going to set on this is the OpenAI API key, OpenAI API key. So for me, that's going to be my API keys, and then my OpenAI API key. And then I guess we could set the model. Well, I guess the model is set to default the GPT 3.5 Turbo, and that's okay. I don't need to. I don't need anything more than that. Okay. So the way that this used to work is we're gonna need to do one more import here. Is and you might recall this from old streams. Is if we wanted to chain this prompt into this LLM, so basically like these things are always working in tandem, what we had to do is that we had to do another import here. So from LangChain.chains import conversation chain, and kind of hope that this object would work. And what I mean that I kind of hope that this object would work is that like there are actually multiple different kinds of chains here, and depending on what you need, you may or may not get this object right. And so I'll demonstrate this here in a second. So using this legacy object here, so legacy, let's call this legacy chain. Legacy chain equals conversation chain. All right, so the LLM, we need to pass in the LLM equals LLM, and then the prompt, LLM equals OpenAI LLM, and then the prompt is going to be what we pass into here, so the chat prompt. Okay, and so then when we invoke it, okay, yeah, so here's one of the problems that we're already running into, is that like this conversation chain object also does a history save. So what I mean by that is like, so by default, like let's set LangChain aside completely for now. If you were to just invoke the OpenAI API by itself and you were to ask it questions, it is not saving a state on its side. And when I like through the API, that is. And when I mean it's not saving a state on its side, I mean it's not saving the history. So if you ask it, what is the capital of Illinois? And then it says, Springfield, and then you ask a follow-up question immediately, and you say, what is the largest city in that state? It's not going to get that answer correct, because you need to be explicit whenever you're working in a programmatic scenario about passing that history back into the API. So for this conversation chain here, and that you can start to see the problem a little bit, is that this conversation chain here requires that you have some sort of history within inside here. And then it requires within the human message prompt that you actually pass in this history from the inputs, so now I have to go back and refactor my code and kind of hope this works. And I actually personally, for this actual use case here, I don't need the memory. And so you're starting to see like some of the problems of just trying to use the old chaining style, because now I got to go find an object that actually is more appropriate for me. And that's kind of been problematic, and I don't necessarily want to do that. So let's go ahead. I'll go ahead and refactor this for now just to get this working, but I don't like it. So what the refactor here is basically at the point, like every time we invoke this model now, is it will be saving the history back and then passing it back through as this little object thing here. So let's go ahead and run this now again. All right, but history is inputs from memory, and input is the normal key. Normal input key. All right, what did I do down here? I don't even remember what I did. I'm looking at my notes. Okay. Oh, does it also need this maybe it does need this very explicit input set as such. Okay. All right. I was wrong. Apparently you do need that input set as such. I guess it's not a big deal to remember this though, because we're showing the old way right now, just as a comparative purpose. But you're again starting to see the rigidity and some of the not so funness of using the old chaining style. But it still works, technically speaking. So like this legacy chain, we can now invoke. So response equals legacy chain dot predict, and then our input is going to be what is the capital of Illinois. All right, and then let's go ahead and print out that response. Print the response. Okay, so give that a second. All right, so there's the capital of Illinois. Now I'm just curious, I actually did not look at this before. Okay, so you can see in here now that within this conversation chain object, so we have this conversation memory buffer thing here, and I don't know if you all recall this, but the conversation memory buffer thing here, this is one of the standard memory types that you can use, because there's different memory type. That's the other thing that gets kind of tricky, is there's different memory types within LangChain too. So like this one's the standard one, and so you can see here that we within our history we've asked what is the capital of Illinois, and then we get this response back. So now I guess this is kind of the one nice thing about this legacy chain, although this is not preferred behavior for me, is if I were to copy this back down, and if I were to ask the question, what is the largest city in that state, I should get the answer Chicago. What is the largest city in that state? So let's go ahead and see. Okay, so it knew that the largest city was Chicago because it saved that history. But again, if you want ultimate kind of freedom to be able to do what you want, using these objects is not great. So I hope you're starting to see why they started to move away from this and started to move into what we're now going to move into now. Here, didn't mean to do that. So I just want to very clearly delineate. Moving on to LCEL. So let's go talk about the LangChain Expression Language now. So this kind of remedies a lot of the problems that we were seeing before with what we were starting to kind of get into up here. All right, so let's go to LCEL. All right, so what is LangChain Expression Language? So LangChain Expression Language is basically this new syntax kind of variant thing here, where they make use of, here, let me just zoom in on this. So this is one of the classic examples, or one of their examples that they're showing here, is that you can now use create a chain by using this pipe syntax here. So for those of you who work on Linux kind of things, you'll recognize the pipe syntax here. So anything on basically the left side of the pipe, or I guess you can say in this scenario above the pipe, gets the outputs of whatever is above here gets fed into the inputs here. So you can see that we can very seamlessly kind of pipe these things together now. And the way that that LangChain was able to get by doing this is because they have standardized the framework of all these different objects here. And when I mean a standardized framework, I mean like they have very specific methods that you have to call and a very specific input and output schema. Now, this is not ideal for most IT scenarios, but for LangChain, this actually works pretty well because we're working within language modeling. And working within language modeling, obviously the things that we're working with most often include metadata and the textual data itself or embeddings. And so it's kind of, when you're working with a narrower domain like that, you can get away with doing what LangChain is doing here. And so what they're doing is they're basing this all on this thing called runnables. You can kind of see it here. Now, a lot of this is kind of extracted away, but the reason I want to talk about these runnables is that like these runnables are the way that like they've kind of standardized the input and output kind of schemas here. So like let's look at the interface then. So like for example here, so like here's the different components of LangChain, and here's how they've kind of standardized things. So if you're now using like a prompt, and like your standard input's going to be like a dictionary, and your standard output's going to be like some sort of prompt value. Or if you're using a chat model, then your standard input's going to be some sort of, it's either going to be a string or a list of strings or a prompt value. And when they mean prompt value, so this is like the object that's coming out of like one of the objects that's coming out of this thing here. So like, in fact, let's just go ahead and look at the response really quick. All right, so the response. Oh, I just meant, that's funny. I remembered that I asked that twice. So type of response, what is, that's just a string. That's interesting. Okay. Oh, that's because we're not using LCEL for this. Never mind. Yeah, that's why. But if we were using LCEL here, what we would actually have is that this response type would be a very specific LangChain object called AI response. So that's kind of what this prompt value is referring to here. And then so you can see that there's other like kind of standard inputs and outputs here. And you can see here that within the runnable interface, this runnable protocol, it is expecting these kind of things to always be, these kind of methods to always be available. So you got stream, which is streaming back the, the tokens as they're generated, very much like ChatGPT's user interface does. Invoke's kind of the standard one, invoking a chain on an input. And then batch is just like it sounds, as batch. Yeah, so that is the great value of LangChain. And then you can do like even special kind of things. So even if you can't find like a component that necessarily works for you, that's okay, because they have this nice like how-to kind of cookbook over here of all these different runnables that you can do. So if you want to have parallel chains, or if you just want to have your own custom functions or some specific branch, you can do all that. Now we're not going to get that deep into this. I just want to get to the point where to highlight that this is kind of how this LCEL framework kind of works now. And so let's go ahead and demonstrate how we can use this with OpenAI, and then we'll move into using this with MLX specifically. Okay, I keep going to that wrong. So you're getting a preview of another stream I'm kind of interested in, and that is like I want to do something on RAG, but there's not really any good data sets out there. So what I would prefer is like a large corpus of documents where each document is rather long, and the reason, not super long, but long enough to demonstrate chunking abilities. And I can't find one, so it's like, all right, well, if I can't find one, I'll create one myself. So that's probably, you're getting a preview of an upcoming stream that probably won't be around for another month or so, but there you go. Anyway, I got a little bit sidetracked there. Okay, so all right, let's go ahead and do this all again now, except now using LCEL. All right, so I'm going to keep this really simple this time. So I'm going to keep the LLM is going to be the same, but just to really drive it home, well, actually, let me just copy and paste this down, because this is really just going to be the same. So the OpenAI LLM, this is already set up for LCEL, so this is already good to go. And then, so if we wanted to set up a new chat prompt, I'm going to make just a very simple chat. Well, no, I actually am going to make the full thing, but let me copy this on down again. Chat prompt, because these chat prompts and things are also already good to go for chaining together. So except I'm going to remove the history now, because now I don't have a concern of history to be worried about. And so basically what we need to do now is just chain this LLM to this chat prompt. And so the way that we do that, let's call this LCEL chain, LangChain Expression Language chain, is very simple. Now we just do an OpenAI pipe syntax, chat prompt. Oh wait, I'm sorry, I got that backwards. Chat prompt, then pipe that into the OpenAI LLM. All right, and then like I said, so then we can use we have these standardized functions here. Where's the standardized function for this? So yeah, standardized function here being invoke. So now we can go response equals LCEL chain dot invoke, and then we can set the input to be, all right, so what is the capital of Illinois? What is the capital of Illinois? All right, and then now let's look at the type of the response object here. So this I think this is different now. Oops, might help if I spelled that correctly. Okay, so yeah, this is what I was talking about before. So where's the interface thing here? Okay, so where I was talking about like this prompt value thing or this chat message thing, that's what this is referring to. It's basically like LangChain's version of their inputs and outputs and whatnot. And so that's the type of the response. So let's go ahead and print out the content of the response. So print response.content. Okay, the capital of Illinois is Springfield. All right, very good. And just to make sure that this is actually working well, so I know this is a rather silly example, but the reason I use it is just because it actually does drive it home that this is working well. You are Jar Binks from Star Wars. I know y'all are probably tired of me using this example, but again, it really does drive home that is different. So yeah, you can see that, you know, even though this is our input question and it's being fed into the human message prompt, that we are still getting the system message prompt still working appropriately here. All right, so let's go ahead and change that back for now. You are a helpful assistant. Okay, so that's how LCEL works. And now you can see, so now the cool thing is then you can start to see how you can start swapping out LLMs very quickly. So let's actually, I'm getting ahead of myself a little bit. Let's move on to MLX. Now let's go into the LangChain framework again. So the LangChain framework, or I'm sorry, not the framework, the wiki here. You'll notice it's this one tab up here called integrations. And so integrations, we were starting to mention here on the page here. So we have this new like community library. This is where anybody can go, because this, you know, LangChain is open source, and you can add like your own integrations for your own very specific products. So you can see all these different packages and whatnot, and you can see all the different LLMs. And so there's a bunch of different options in here. However, as of today, there is not an option in here for MLX. So what do? Well, no problem. We can just, you know, the way that LangChain is set up is that it's you can still kind of use your own custom kind of thing if you would like. So in fact, let me just show you LangChain custom model. So this is the page that I actually followed, and this is the page that we'll cover here in a little bit. This is actually not what I wanted. I wanted custom chat model. LangChain custom chat model. There we go. So yeah, the custom chat model here. So this is basically, this is exactly what we're going to be doing. And actually this is what the OpenAI is actually doing as well. So we have this base chat model here. So this is a LangChain object that was already created. And actually these LangChain objects, these specific ones, are created on top of another Python framework called Pydantic. So if you're not familiar with what Pydantic is, so a lot of people who work in Fast API might know what Pydantic is. It's basically this library that helps to facilitate inputs and outputs to make sure that like the data types are correct or the data values are correct or whatnot. And so that's actually what this base chat model is. In fact, let me find, I wonder if I can find the source code really quick for that. Source code. Because actually I found that the LangChain source code is actually pretty readable and easy to understand. So let me go over to the partner labs and then OpenAI. chat OpenAI. And where's your source code? Okay, so you can see, where is it at? Okay, so this is it. You can see, so this is the chat OpenAI object. This is the exact same chat OpenAI that we've been using so far in our notebook. So that's the, where's it at? Yeah, so you can see here, chat OpenAI, and you can see it's inheriting this base chat model here. So let's go into that base chat model and just look at that, what that's doing really quick. All right, where is the source code? Because I want to draw attention to something that I've kind of learned throughout the last couple months that I wasn't very aware of, but I've become more aware of. And so I want to highlight this ABC thing over here. And so if you've never seen this before, this is actually, what does this stand for? I don't remember what it stands for, but basically this is how you can set what is called an abstract method within Python. And so what an abstract method does is basically says, okay, I'm going to set this blueprint for whoever wants to inherit from this. You can do that. However, we're going to enforce that you do the things that we want you to do. So like I said, you with the whole runnable LCEL LangChain kind of framework now, it wants you to overwrite this invoke kind of function or these other kind of functions, or it doesn't want you to neglect. There's one down here where it's like a metadata field that it does not want you to neglect. Like it enforces to make sure that you have that in there, or else it kind of screams at you. But it's very easy to get up and going with, and you actually don't have to overwrite everything. You just have to overwrite a few things. It sounds way hairier than it actually is. It's actually not too bad. So let's just go ahead and jump into the code to show how to do this. All right, so like I said, we need to create a new object, so a class object. So I'm going to call this MLX chat model. Okay, base chat model. Remember, we are inheriting from that. Oh, I'm going to have to do a lot more imports here. I forgot about this. All right, so we're going to need to do a lot more imports. All right, so from LangChain underscore core dot language models. By the way, if this notebook is harder to follow along with, as always, I got my cleaner notebook that's over on the side, and this one's already pushed up to GitHub. So if you want a cleaner notebook, feel free to reference this other one. But let's jump back into our live one here. Just checking for questions. No questions. Okay. All right. So language models import base chat model. So this is again the thing that we're going to be importing from, and then we're going to need a couple other things, and I'll explain what these things are as we get to them. So, but I'm not going to worry about explaining them right now because it's too soon. Like I said, so we're going to import some stuff here from Pydantic. We'll talk about what these things are in a minute. Field. We also need to import from LangChain. Like I said, lots of imports. Dot messages import base. Okay. From LangChain core dot outputs. Import chat generation and chat result. Again, we'll explain all these things here in a little bit. They're pretty self-explanatory once we get to what they're doing. And then, so that's all the stuff from LangChain. I guess I do need to import some typing things. So if you're not familiar with this, by default, like Python kind of infers the data types that you want, but if you want them to be very explicit, you have to import these things from the typing library. And so these are things that are going to be required just because this is how LangChain does things. Not a whole lot of complexity there. All right, so there's the typing stuff, there's the LangChain stuff. So let's import MLXLM, which is actually going to run our models on our local hardware. All right, so I'm going to import load. I'm going to call this as MLX load. It doesn't matter. I'm just trying to drive it home, be very clear with my communication here. All right, so from MLX LM import generate as MLX generate. Okay, so now we've done all of our imports. Now we can move on. Okay. All right, so the first thing we need to do is we need to set a couple of attributes here that whenever we instantiate this class here, that we want to pass in. So again, we are inheriting from this base chat model, which is inheriting from Pydantic. So this is going to be look a little bit different than maybe what you're used to with traditional classes. So with traditional classes, you're probably doing this thing of, init dot and then blah blah blah. You pass in your inputs this way. Again, because we are inheriting this from this, we are going to be doing things a little bit different to adhere to what Pydantic typically sees. So we're just going to call these pretty directly. So we're going to pass in a path to what we what model we want. So remember the way that MLX. Let me actually just review this just very very quickly. So this is what we reviewed in the last stream. So here's exactly what's going on, is that when we use this load function here, we pass in a string, and this string can either be a local directory of like a model that we've already used. So if you recall, we quantized our own model, or you can actually just pass in a raw string from something on the Hugging Face hub, and it will download and make use of that model. And I may or may not do that within this stream just to demonstrate that, like, yeah, that actually works. But the only reason I wouldn't is just because it takes a little while to download those artifacts. So yeah, let's go back into this notebook then. All right, so we want to pass in that path, and then in order to. So like very much like a standard Python class, we need to be able to save some of these objects back after they're loaded into memory. So for example, we need our model to be saved. So what I'm going to do is I'm going to say this is going to be any, because I don't know how to enforce the typing on this super well, just because it is like a funky data type. So I'm going to just say any, and then we're going to use this field thing here to say by default we don't want anything. Like when you invoke this thing, we don't want like the user to pass in this thing, because we're gonna show how just by passing in the string we can load it in on the fly through like a cheating kind of way. I say cheating kind of way just because I don't know if it's actually legitimately the way you're supposed to do it. All right, so same thing over here. So tokenizer equals any. Oops, I'm sorry. Colon any equals field default equals none. Exclude equals true. And again, you wouldn't have to do any of this if LangChain has a native integration, and it would not surprise me if somebody actually builds a native integration for MLX and LangChain. Shoot, it might be me. I'm already doing it here. I'm already halfway there. I actually don't have it fully thought through and completed though. All right, so int equals field default equals 1000. All right. So again, so when we instantiate this model class here, the reason that we have these field options here set with defaults or excludes or whatnot is because I'm okay. So we definitely need the MLX string path. Like, so if you try to invoke it without this, you're going to have a failure. I am okay if you pass in the max tokens, so you can overwrite this field, but I do not want people passing in models or tokenizers, because again, we're going to load that here within ourselves. All right, so one thing, all right, so speaking of loading that within ourselves, so this is the thing that I was talking about, that I don't know if this is the right way to do things, but this is how actually the OpenAI people are, like library is doing it. So let me go back to here and directly show that. I've had a good time reading through the source code for LangChain, and I'm being serious. Like, it's actually been it's very easy code to read, I think, and it's been very useful to kind of understand what they've been doing. All right, so all right, where is it at? So this is the class here, the chat OpenAI class, and so then if we come down to here, yeah, so this root validator right here. So basically what happens is, what this root validator is supposed to be intended to do is, remember, this is a Pydantic object. Basically what it's doing is when this object gets stood up, like, so let's say I'm instantiating this object and I pass in the string. Even though I am saying I'm passing in a string, this root validator here actually allows you to define your own custom function to actually do a little bit of a deeper dive into your stuff to actually ensure that it is actually properly validated. However, the way that OpenAI is using it here is it's actually just using it as whenever you actually instantiate this object here, it just sets up the calling client and whatnot. And so we're basically going to be doing the same thing. So I actually don't know. So again, I don't know. This is not the intention of this function here. The intention of this function is supposed to be a validation, not a way to load models. So that's where I say, like, I don't know if there's a better way to do this, but this is what OpenAI is doing, so I'm doing the same. All right, so this is actually a very specific kind of function. Like, we can name it whatever we want, but you do have to pass in this CLS and this values kind of thing. And I don't think we're even going to use the CLS kind of thing. All right, so we set our validator. All right, or I'm sorry, our decorator as such. So we're going to create a function here called load model. We're going to again, we need to set these input values as such, and then we need to force an output value of a dictionary. Again, that's just how this thing works. And then so we're going to say loading the model and tokenizer with the input string. Okay, and so the way that we're going to do that is model tokenizer equals MLX load, and then we need to pass in this string here. And so this string is, so this is what this little dictionary of values, I'm going to call that values. This dictionary of values is actually just passing in this here, and then at the output, it's going to basically save all these back. So so what we're going to do here is we're going to say values MLX path. Yeah. Okay. And then we're going to save these respective variables back into here that we can then later use at inference time. So saving the variables back appropriately. All right. So values MLX model equals model values MLX tokenizer equals tokenizer. Okay. Return values. Okay, so that is loading the model itself. Now we just, we could do more than this, but the only other function that I am going to create here is overriding the generate function, so that way when we can actually invoke this thing with LCEL to get results back appropriately. Okay, so we need to create another function here. We're going to call this def generate. So again, we are overriding this function that we are inheriting from the base chat model in here. So we're going to pass in self, and then we're going to pass in the messages. So this is stuff that does have to be very much just like this. So this is why we had to do some of these special imports. So like this messages, again, this is even though this is a little bit confusing to see, this base message here, just as a reminder, coming back up to here, when at the end of this thing, when this thing starts spitting things out, that's what basically this base message here is. It's just another instance of this kind of class here. It's just, I know it can get a little bit confusing because even if we come back into like here, or where's the interface? When we come back into here, they call it prompt, or I guess they do call it chat message here, but they call it prompt value. I don't know. Like I get a little bit confused by the names, but just that's what it is. Like, so anyway, we need to pass that as the input. Now we actually do need to pass in this next value, and to be completely transparent, I just didn't have enough time to research why it was not working without this, but basically you need to pass in this stopping token, but for our purpose, like it's not going to do anything, but I need to pass it in anyway. Like, again, I just don't understand why we need it, and I'm doing a poor job of explaining it. Sorry, I was just looking at my notes because the syntax is wrong here. Okay, does that look right now? All right, and then we need to produce a chat result as the end of this. And again, this is all just kind of mapping things onto what their recommendation is here for implementing your own custom chat model. So in order to get the custom chat model working, you have to save things out as a chat result. Again, it sounds complex, but it's actually not. So like I said, so what we're actually going to be doing is as we take in each of these chat objects here, so the system message prompt template and this human message prompt template, we're just going to take the values, the string values within inside those, and then just append them onto our own string before we pass them into the MLX model. So first thing that we need to do then is we're going to just create a prompt with an empty string there. And this is going to be the thing that we're just passing things into. All right, so we have our messages here. So our messages, in this case, it's going to be the two different objects. So again, it's going to be first the system message prompt template. So that's just the "you are a helpful assistant," and then it's going to be our input from the human message prompt template. So we're just going to say, so this will be a list. So for message in messages, So we're just going to say prompt plus equals. So we're just going to append on whatever the content is here. So I'm going to create a couple new lines. Or I'm going to use an F string here. So I'm going to say new line, just to create a couple new lines, just because this does not matter. This message.content. Okay, so that's just getting the message. And now we're just ready to pass it back in to MLX and get the response back. And so again, just as a reminder, so this is what we did in the last stream. So just using this MLX generate function, we pass in the model, we pass in the tokenizer, we pass in the prompt, and we pass in the max tokens. And we can pass in other things, but those are just the minimal ones that you have to do. So basically, we're just going to use this exact same thing here. So all right, so we're going to call this MLX response. Response equals MLX generate. All right, so now we're going to pass in model equals self.mlx model. Tokenizer equals self.mlx tokenizer. Max tokens, max token, MLX max, I'm sorry, oops, self.max tokens. Oops, I forgot to put the S there. There we go. And then we're going to pass in just a prompt. Prompt equals prompt. All right. So that is all we need to do. Now we just need to return this back appropriately. And so again, we did a bunch of imports here, and this is going to look hairy, but it's actually not. So this is just chat result, generations equals chat generation, message equals AI message, content equals MLX response. Okay. Why is that still grayed out? Generations equals. I'm just going to copy and paste this because I think I probably have some goofy syntax error or something that, or I probably have like a parenthesis out of place or something like that. Okay, oh, that's because I don't have it indented appropriately. That's why. Okay, so just to recap what we did there again is, so again, we have the raw string coming out of our MLX model as this MLX response, and we're basically just wrapping it in this this format that LangChain wants it back in. So first we set it as the AI messages response, and then we set it within this chat generation framework, and then we put it back in within this chat result thing. And again, that it seems complicated, but really the meat of what we're interested in is right here. So that's the object. Now, I actually did intentionally make a mistake here, and you'll see what that is here in a second. So I'm going to call this MLX LM equals MLX chat model. Actually, I need to set some pathing here. I'm just going to grab it from here. All right, so just as a reminder, hold on. So, oops. We had saved our quantized version of Mistral AI to this directory here. So we're basically just going to pass in this directory back in. We're going to call this MLX path equals MLX model directory in order to load our quantized version of Mistral. Now, you'll see it should have a problem here. All right, so there you go. Cannot instantiate abstract class MLX chat model with abstract type method type LLM. So this is what I was talking about before, where underneath here is they have this abstract class, and I have not enforced something in here, and so there is this one metadata field that I intentionally did not add, just to show that if you don't include things, that it will get mad at you for not including them, and this is one of those. It's just very simple. So we're going to say that this is a property value def LLM type self, and then we want to output a string. Again, this is just a very specific kind of thing to LangChain. Return MLX chat model, because basically it wants to see what we're calling this chat model, and so it's referencing this type here. And so now if I run this, now it should be okay. So it's taking a little bit because it's actually loading the model in memory. And now we could simply use this within our framework. So as a reminder, so this is our chat framework here, and so now we can say MLX chain equals chat prompt. So remember, we are passing in our chat prompt, and now we're just going to pass it into the MLX model. MLX LLM, I'm sorry. And now let's go ahead and invoke this thing. So response equals MLX chain dot invoke input equals input. What is the capital of Illinois? Okay, so this is referencing my locally quantized Mistral kind of thing. What? Oh, none type has object. Huh? Did I not do something correctly? Hold on. I think I did not do something correctly. This was working last night. All right. Let me just copy from over here just to make sure, because this is the where I was working from. All right. Okay. $39, $40, $41. Oops, my bad. Okay, it looks like it worked this time, so I must have just had some silly syntax error in there. Okay, so well, let me just show you the type. So the type of this response now is the exact same type as the response that we got from above. So this one up here is the one that we got from OpenAI specifically. So you can see here now it is the exact same type. And now if we do response.content, then you can see that we actually get our response. I forgot that Mistral's a little bit chatty. So OpenAI tends to be more straight to the point with these kinds of questions. All right, so now let's show the real value in doing these things, because now what I want to show is how you can very quickly iterate through individual models using this framework now. So what we're going to do is I'm actually going to I'm going to have 3 models going. So we've already shown 2 of them. The second one I want to show is, so I'm a Perplexity AI user, a Perplexity AI Pro user. And so one of the very cool things about Perplexity is Perplexity AI is that we can, where's their API documentation? I'm kind of scared to show, I'm kind of scared to click on that because I think last time I accidentally revealed my API key, which was not good. Let me just see Perplexity API. Okay, there we go. Now I won't show my API key by accident. All right, so our guides. No, I want to show the API reference, or maybe it is guides. Supported models. Okay, so basically what Perplexity is, it's a UI service primarily, very much like ChatGPT or something like that, except it is connected to the internet, and you do get to select your model on the back end. So like I'm using like the new Claude 3 Opus model on the back end for mine. But as part of a Claude 3 Pro subscription is you can also you get $5 a month to call their API on the back end. And so their API hosts these different models out here. So you can see that we've got their own implementation of Mistral 7B, non-quantized, but they also have Mixtral in here, which I think is really cool, and then their own proprietary models. But let's go ahead and use Mixtral just to show like the different kind of responses that we can get from these things. All right, so let's go back into here. I'm gonna copy this back on down one more time. I know we're getting tired of saying this, but just to really kind of hammer this thing home. And I'm actually just gonna I'm gonna actually set this prompt as this input prompt. Input prompt equals input. What is the capital of Illinois? All right, again, nothing new here. Just bringing this on down for very clear clarity. Very clear clarity. Yeah, there we go. All right, so what we're going to do is, so we're going to have model types equals, so we're going to have our 3 models. So we're going to have OpenAI, then we're going to have the Perplexity Mixtral, and then we're going to have our MLX Mistral model, just to show the 3 comparisons. All right, so now we can go for model type in model types. All right, so now we can say we're going to print out a statement just saying we're currently testing the following model, and then model type. So just doing a quick print statement there. All right, so now let's load each of the models. So if model type equals So if this is OpenAI, then we want our model to be chat OpenAI. All right, so this is going to be the exact same thing that we did before. So just setting the OpenAI API key, API keys, OpenAI API key. So that's setting the model for that. All right, so now let's say instead we want if model type, if it's equal to perplexity mixtral, then we're going to set the model type to be, so mixtral is actually a little bit interesting the way it works. So if you want to use it within an API reference, it actually manifests itself as like an OpenAI kind of thing. Where is that at? Getting started with the OpenAI thing. Yeah, so you can see here, this was very confusing the first time I looked at this, but basically we are passing in the base URL and our own API key. So it kind of looks like it's OpenAI, but it is actually a Mistral behind the scenes. So all that to say is we're still going to use the chat OpenAI object, except we need to set a couple different things in here this time. So we're going to say API key equals API keys. So now instead of using the OpenAI API key, I'm going to use my Perplexity API key. And then we're going to need to set base URL. So base URL, so this is that very specific URL that they provide, api.perplexity.ai. And then model equals, so this is where we are going to set the specific model that we want to call 8x7b instruct. Okay, so that is our second model, and then we're going to set our third model type equals what do we call that, MLX Mistral. Then we're going to load in our MLX model. So MLX model equals MLX chat model, MLX path. Now I actually kind of do want to test this out. I don't know if this is going to work, but so let me go ahead and go into the Hugging Face hub, huggingface.co, and let's grab a model from the Mixtral community that's already quantized and kind of small, preferably. So let me see most downloads. All right, so these are like all the quantized ones. All right, so this Gemma 2B, I don't think I've ever worked with that one yet. And it's instruction tuned, but maybe I have. I don't know. Let's go ahead and try this one out. Just to really drive home that we really can use any MLX quantized model as part of this. All right, so MLX path equals that. So actually we're gonna call this Gemma. All right. So then we can set our chain. So now that we've set the model, then we can set the chain here. LangChain equals chat prompt. So this is not going to change. So this is just coming in from here. And then we just set on our model as such. So again, it's just going to swap it out each time that we run this thing. And then we could add as many as we wanted in here without having to change the whole syntax of everything, which is kind of the beauty of LangChain. And this is very simple. Like we can actually do a lot more with LangChain, and we will in upcoming streams. But this is going to just suffice for what we want to do for our purposes here. So we're going to say response equals LangChain.invoke. So again, because they all follow a standard syntax, we can be sure that that invoke function is there. And so we're going to pass in our input prompt, and then we're just going to print this out. Print f response.content, and then I'm just going to create some new lines, or a new line. Just oops, why did I do that? All right, so let's go ahead and run these. Now I'm kind of nervous about the third one. All right, which one did it? Detail method not allowed. Uh-oh, which one was this? For MLX path invoke. Yeah, but where did it get stuck at? Oh, I probably, did I not set something right in here? Here, I probably did not set something right in here. Hold on, I'm copying and pasting some stuff down. All right, so let's try this again. Okay, yeah, I forgot the S. Darn it. HTTPS. Darn it. All right, there we go. All right, so we already got the first answer here. Now you can see that we are actually, so because I do not have this Gemma model downloaded, it is having to do the download first, and then it will load here in a minute. So this is going to take a little bit, but just recall that anytime you download one of these models, it does get cached, so then it's a little bit faster going forward. But yeah, I just really wanted to highlight that this does work regardless. So you can see here, we've already gotten our first two responses from, so here's the one from OpenAI. Next one down here is from Perplexity's or Mixtral as deployed by Perplexity. And then hopefully here, it won't take too terribly long to get the artifact. Oh, wow, it already did it. Okay, so we already fetched the gem artifacts, and it already produced the response here. So sure, the capital of Illinois is... now, is there anything else I can help you with? Now, if I were to run this again, we shouldn't see these download kind of statements because that should have just been a one-time thing. But let's try it out. Or maybe... Okay, yeah, it looked like maybe it was loading from a cache there. And yeah, so you can see that we got the responses here. And yeah, so that's MLX. And so then we could go back and alter this to work for streaming purposes, work for batch purposes. This was just a really simple implementation because this is going to end up being our backbone for the Gradio UI we're going to build in another upcoming stream. Okay. All right, that was a nice hour there, a nice, cool, breezy hour. So I hope you all see the value on this thing. Like this was a really fun kind of project for me to work on, and I'm excited about it. And I'm excited about the Gradio UI we're going to build around this. So, yeah, LangChain's a really cool framework. Big fan. I'm a big fan. It was a little bit confusing to get up and going with this LCEL framework, but now that I deeply understand it, like the whole runnable kind of thing, it's actually pretty cool. I am a fan. All right, so we'll go ahead and end it here. I don't see any questions or anything, so hope you all enjoyed this one. There definitely won't be a stream next week. I'm traveling next week, so don't have the chance to do anything next week. However, I'm working on other things, so definitely expect more streams soon. Hope you all have a great weekend. Hope you have a great Easter, and we will see you in the next one. Thank you.